and welcome to my lab. I'm especially pleased that you are here to celebrate this very wonderful anniversary. And I want to thank the UW band for being here. Weren't they great? They'll be back. They'll be back. So thank you very much. Appreciate your being here, and we'll see you shortly. So I ask you to pay attention, because if you pay attention, you're going to learn. And I want to make sure that you are really paying attention. What does my T-shirt say? Oh, come on. You can do better than that. What does my T-shirt say? That's it. We need to have some enthusiasm as we do experiments. And what I want to do now is a set of experiments with carbon dioxide. Carbon dioxide at room temperature is a gas. It has no color. We can't see it. And it has no smell. We can't smell it. But I'm going to do an experiment with solid carbon dioxide. The solid carbon dioxide is called dry ice. Dry ice is at a temperature of minus 78 degrees Celsius. So I'm going to put these gloves to protect my hands from frostbite. I'm going to take a chunk of dry ice and put it right here. It's very, very cold. These gloves are not very good insulators, but for this purpose, they're good enough. Dry ice changes from being a solid to a gas directly without melting. When something changes from being a solid to a gas directly without melting, we call that sublimation. Can you say sublimation? Sublimation is happening right now, but we can't see it. How come we can't see it? Because carbon dioxide gas is invisible. It's colorless. So now I ask you to focus your attention on what you see between my two hands here. What shape objects are they? Cylinder. They are cylindrical, and how many of them are there? 6. And they seem to be arranged in pairs. This pair has what color liquid in them? Blue. This one. Pink. And this one. Purple. And they all have liquids in them because if I shake the table, or if I shake them gently, we know what liquids do. We know that from experience. We always try to make connections between what we know and what we are experiencing right now. That's why we learn how to memorize things. We memorize things so we can use them. So let me ask you, are you able to see the colors better this way? Or without the card? With the card, all right. I'll put the card like that. And these 6 cylinders have in them colored liquids. And I'm going to take chunks of dry ice and put the chunks of dry ice in the cylinders in a very special way. And when I get done, you're going to tell me what that special way is. Did I put the dry ice in every cylinder? No, I put it in every other cylinder. And do you see any changes? Lots of changes. You see color changes, you see bubbles. Those bubbles are carbon dioxide bubbles. They're coming from the sublimation of the dry ice. We don't see the sublimation right here because gas is mixing with gas. Over here, gas is mixing with liquid. In fact, we also learned from this experiment that carbon dioxide gas is not very soluble in water. Otherwise, we would not be able to see the bubbles. And the color changes are because I put in some dyes there that change as the acidity of the liquid changes. So I put these dyes, and these dyes have their own names. In this pair, it's called bromethymol blue, and there's the pH scale that you can see. And you can tell that the pH is lower now, meaning that the liquid in this cylinder is more acidic than the liquid in the blue liquid in the other cylinder. The indicator that is in the middle set is called phenolphthalein, and in this case, the color changed from pink to what? This is a clear and colored liquid. This is a clear and colored liquid. This is clear and colorless. From now on, no one is going to confuse the words clear and colorless, right? We learn and we use what we learn. And then the last set of cylinders that I have had in them a mixture of the indicators. They're called acid-base indicators. the color change indicates to us that a chemical reaction has taken place, and you can see the pH is going down. In other words, carbon dioxide is making the liquids more acidic. And we have to be careful about something called ocean acidification, because carbon dioxide, which is a greenhouse gas, is affecting our planet. Is affecting our planet in not such a good way either. You know, greenhouse gases are good for us. If it weren't for greenhouse gases, the temperature on the surface of the planet would be as it is on Mars. Greenhouse gases are good for us, but too much of anything is not good. And the main culprit is carbon dioxide gas that comes from the emission of burning fossil fuels. So that's something we have to be aware of, have to enjoy the chemical transformation, but we also have to be careful in how much we rely on fossil fuels for energy. You notice that on the very top here, we have something coming out that looks like smoke. It's not smoke, it's actually a mist. And I'm going to do an experiment with the hot boiling liquid that I have here. The one that I have here is water. I'm going to use my gloves now to protect my hands from heat. And I have some dry ice here, but actually I'm missing a dishpan. Let's see if I can find it. Could someone please bring me the dishpan? Would someone please bring me? Hello, Bucky. Good to see you, Bucky, and welcome to my lab. Thank you. This is what I really wanted to do. So Bucky, would you like to help me with this experiment? You notice that Bucky is a good science student. He's wearing his eye protection. I want everyone to see that. And so, Bucky, here's what I'm going to do. I'm going to take the boiling water. I'm going to put it in this dishpan that you brought me. And what we see coming off the top here, what does it look like? Steam is invisible. You can't see steam. We see a mist. That's what we're seeing. The mist of water vapor. And then, Bucky, here's the experiment. You take this bucket right here, and you pour all the dry ice that's in there into the boiling water. Go ahead, Bucky. Do it, all the way, all the way. That was very, very nice, Bucky. Does that look like steam? No. It looks like fog. Looks like fog, and that's what it is. We just made a lot of fog here. You notice that the fog is moving downward now because carbon dioxide gas is denser than air. The condensation is on the carbon dioxide gas that's coming from the sublimation reaction. Bucky, I know you are a very studious student at UW-Madison. I know you are. And you're going to... How long is it going to take you to graduate, Bucky? Let me see that. Yeah, up there, I see. Wait. It's going to take you 4 years to graduate. Wait, you have 4, I have 5. I guess we are different. Yeah. But I'm glad you want to graduate in 4 years, and I know you are very busy now with the final exams coming up, and you want to go study, you want to go review. So, Bucky, thank you so much for stopping by here. Thank you very, very, very much for being here. For my next experiment, I'm going to use something that everyone in the audience is very familiar with. I'm going to use a baby bottle and a can of soda, seltzer. This baby bottle has been slightly modified. I have replaced the nipple that has the hole in it where the milk comes out. I've replaced that with the rubber bulb from a medicine dropper. And I'm going to try to show you how strong this piece of rubber is by attempting to blow air through it, see if I can inflate it. Okay, here we go. Cannot do it. It's a very, very strong piece of rubber. So now, listen to this very familiar sound as I open the can and then pour what's in the can into the baby bottle. What do you see? Fizzing. You see bubbles. Those are carbon dioxide bubbles. They're coming out of the liquid because the pressure has been reduced. So I fill the baby bottle with this liquid. I put the screw cap on. I tighten it. What should I do next? Shake it. You've done this experiment before, right? So let's see. Shake it. Now you see how strong the pressure is. It's able to inflate this strong piece of rubber that neither I nor any other human being can inflate with all the powers of our lungs. You know about the carbonation that is in carbonated beverages. Because when you take a sip or two, what do? You burp. Yes, when you burp, would you please do it gently and politely? The carbon dioxide gas comes out of the liquid. Do you know why we like carbonated beverages? Well, some have sweeteners in them. Some have a little bit of alcohol in them too. We like them because when we put the liquid in our mouth, the tiny gas bubbles come out of the liquid and tingle us under the tongue and in the mouth and give us a pleasant sensation. And you know that pleasant sensation is not there when the drink is flat. The sweeteners are still there, the alcohol is still there, but the carbon dioxide is gone. So this is more about carbon dioxide gas, and I'm going to now release the pressure. I made a mess here, but that's all right, right? It's a lab after all, right? But we're careful. And this is a non-sugary liquid, so I don't have to rinse my hands right away. So carbon dioxide gas, again, is a greenhouse gas. It has lots of good uses. It has lots of good applications, but we still have to be careful about using too much carbon dioxide from the combustion of fossil fuels. We have to really, really be very careful. Global warming is unequivocal. We have to reduce our use of carbon dioxide emission from fossil fuels. In fact, the effect of global warming is so great that even in the Arctic, the snow is melting. All right, so now what I would like to do is an experiment that uses a clear and colorless liquid. And what does this look like? And I'm going to put this liquid in this Pilsner, like so. And then I'm going to take a chunk of dry ice, and I need to put my gloves on first, right? Because dry ice is at minus 78 degrees Celsius. And I take this chunk of dry ice and put it in this liquid. And you can see that the liquid is getting cloudy. That's because the liquid has in it a lime solution. It has in it calcium hydroxide solution. And calcium hydroxide reacts with the carbon dioxide that's coming from the sublimation of the dry ice and forms an insoluble substance. But if I put another chunk of dry ice in there, maybe even still a third chunk of dry ice, we can watch and see what happens in these transformations. Can you hear the bubbling? Has anyone in the audience been to Cave of the Mounds or any other cave where you see stalagmites and stalactites? It's the very same reaction that's going on right here, except that it's happening in those caves at a much, much slower rate. And the bubbling is because of the carbon dioxide coming out of the sublimation. Carbon dioxide gas is a very important gas for us to pay attention to because it comes also when we burn fossil fuels. The complete combustion of fossil fuels produces more carbon dioxide than ever. And right now, the biggest challenge of our time is global warming. Global warming is unequivocal. We each have to make considerable effort to reduce our dependence on fossil fuels. You notice now, back to the bubbling over here, you notice that the solution is no longer cloudy. In fact, it has become clear. And that's because more carbon dioxide has interacted with the insoluble calcium carbonate to give us a soluble form called sodium bicarbonate. But carbon dioxide is something that we really, really must be paying very much attention to, because global warming is greatly affected by greenhouse gases. At this time, I would like you to join me in welcoming my good friend, Professor Michael Electron. Hello, Mike.
Hi.
Welcome.
Thank you for having me here.
Professor Michael Electron. Celebrating his 50th year as a faculty member at the University of Wisconsin-Madison.
Thank you so much. Thank you. Thank you. Thank you, Bucky.
Very, very happy to see you, Mike. Thank you. I have a special gift for you to commemorate your visit, and it's right there.
You see that? That's terrific. It's beautiful.
And it's made in my lab. It's made of brass. You have brass instruments in the band, right?
Most of the instruments in the band are made of brass, right?
And they make beautiful sound.
They do.
So this
most of the time.
This is for you to keep.
Well, thank you so much. What a nice gift. I really appreciate that. Thank you.
And in my lab, we work a lot with different chemicals and different metals, and sometimes we mix different liquids together, and sometimes we get a metal. In fact, I would like to do an experiment with you, if you're okay with that.
I suppose I should put on some goggles.
Yes, you should put on your goggles, yes. We always obey the safety rules in my lab. Thank you, Mike, for remembering that. So, what we have here, it still looks the same, right? Give Mike a big hand.
Oh, what the?
So, Mike, if you put the gloves on, I will also put this pair of gloves on, because we have these round bottom flasks, and we are going to empty the hot water that's in them into this bucket right here, okay? So if you pick one up, use both hands, okay? And then just empty the water, just like that, glug, 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 yeah. All the way, yeah, you got it. And put it back on the cork, and I will get this out of the way. And then we're going to mix different chemicals in there. You have a small flask, as I do here, right?
Yes.
And you have a big beaker, as I do also.
I do that.
All right, we take the big beaker first.
Okay.
Right? We put that in there. Clear and colorless liquid, all the way. And then what's in the small flask, also a clear and colorless but different liquid, we put that in. And then we reach for the rubber stopper. We put the rubber stopper on, tight, and we start mixing. You know, for a chemical reaction to take place, we have to mix the chemicals. So we're getting a dark color. Are you getting a dark color?
Yes, it is. It's dark. Darker. And I can see myself in it now.
Oh, I can see myself here, too. So this is what we're doing here, Mike. We mixed liquids together, and we're depositing a nice thin film of silver on the inside of each of these two flasks.
We have a new Christmas tree ornament.
It is the season. Yours looks shinier than mine. You did a much better job mixing the the two liquids together. And so here's what I would like to show you. This was prepared earlier. And of course, Mike, look what it has on it.
I like that. I like that a lot.
Well, you know what? We're going to specially treat this on the inside and give it to you as a gift. You can hang it in your office whenever you like. So, Mike, I have another special gift for you. It's this plastic tube. It's sealed. Could you just bend it a little bit? Bend it some more. Whoops. Yeah. Just shake. Now shake it. Ooh. That matches your jacket here. Yeah.
You know, I could probably conduct a band with this.
All right.
Come out here, band. Let's try and see if the audience can sing along with this one. Here we go. 1, 2, ready, and.
Thank you very much, Mike. Thank you very much.
Thank you so much.
Congratulations on 50 years of wonderful community leadership. Thank you, Mike Electron, and the UW Band. Thank you very much.
Thank you.
Next experiment I'm going to do is one using these plastic bottles that I have here. I have one that I want to show you that has nails stuck on the inside. Actually, they're screws, they're not nails. And this cutaway shows that the screws are separated by a distance of about half a centimeter. So they're not touching. And the other two have the same thing inside. But I want to show you that I'm using a device that generates a spark. It's called a Tesla coil. And here's the spark. You can hear it, but you can't see it. I'm going to try to show it to you by touching one of the nails, and with the lights down, let's see if we can see it. Okay, hang on. There, can you see the spark jumping across the gap? With the lights up a little bit? Now you can see it, right? Now you can see it from the tip of the Tesla coil. All right, so what I'm going to do now is touch one of those screws and see if I can make that spark jump across the gap that separates them, and we'll see what happens. You ready for this? Here we go. That caught your attention, right? Here's another one. You ready? I'm ready. Here we go. You have been a great audience, and I want to thank you for coming here to share in the joy of science, enjoy the arts, and to be enjoying whatever else you do when you do experiments. Thank you very much for coming to this special celebration. I want to invite all my co-workers to come out. Come on.